Okay, great. So yesterday we went through some of the points to sort of get you going with ARCHER2. We went through logging on, running jobs through Slurm, and we had an overview of the development environment, which we're actually going to see in action just now, because this morning's first session is about debugging and profiling on ARCHER2. So we're going to start off by asking what tools are available in ARCHER2, how you can access them, as well as profiling tools. We're going to look at using two tools in particular, one for each of them, and find out where we can get more documentation on them. Okay, so let's get started. So there are quite a few tools available on the system. We mentioned some of them in the programming environment session yesterday. So we're going to talk about them in some more detail now. I would say take a look at the documentation on the website. As ever, that goes into some more examples on using the various tools which are available. There's also a performance analysis workshop that's been run as an ARCHER2 course in the past, and I believe it will be again in the future. And as well as the ARCHER2 documentation on the tools, Cray, of course, have their own documentation because these are Cray tools, Cray developed pieces of software. So to start off with looking at debugging tools, I'll just move this out of the way a little bit while we're just looking at the text here. So we've got 5 different pieces of software here. We're going to be looking at the first one this morning, GDB for HPC. It's a good chance that you may have used GDB before. It's a command line debugger. GDB for HPC works very similarly. I believe it works on top of GDB in the background, but overlays it with the ability to launch parallel programs and collate the information that you receive while they're running. So you get this by just doing, as ever, a module load GDB for HPC. Valgrind for HPC, again, there's a Valgrind you've possibly used before, which contains many different subtools. This is a parallel memory debugging tool. So this can help you find memory leaks, things like uninitialized variables. And like GDB for HPC, it aggregates the errors and the information it finds across the different processes. And that's started up, made available to you in the environment by doing another module load on that. Stat is a tool to give you merged stack traces, and that also comes with visualization tools. You can use ATP through with that as well, the output from ATP, which is something which I believe, let's check, I believe it's loaded at default on login. Is it? No, it isn't anymore. Okay. I think it used to be loaded on login. Perhaps that was on the 4-cabinet system. You can just do a module load ATP, you set an environment variable, and then if you find while your code is running, while your job is running, that there's something like a seg fault, it will give you a merge stack trace that you can then take a look at with stat. And finally, there's CCDB, a Cray comparative debugger that lets you look at different versions of the code side by side, see where the differences are, hopefully help you work out where those differences, which of those differences is causing the problem that you're running into. We're actually now going to do a fairly in-depth walkthrough, I guess I'd call it, of using GDB for HPC to debug an application. So I think I'd really recommend all of you to try and do this at the same time as I'm going to do it here. I think that will be quite illuminating. I think this is quite a fun exercise too. We get to take a parallel MPI code, run it, see it's failing a bit miserably, and we're going to use GDB for HPC to help it out, get it to the state where it can run to completion. So I'm going to make my terminal a little bit bigger here. And here I am logged in. I'm just in my home directory, so I'm going to change into the project's work directory and go into my own one, because remember, we want to be doing everything that we're going to be actually running as a job in work, because the compute nodes don't see the home file system. We have to do it all on the work file system. So here I am in my work directory on the work file system, and I'm just going to make a directory, and I'll call it debugging exercise. Okay. Now the code that you need to get, we can just wget it from the internet. It's just provided through the same URL as the course itself. So if I run this, we've now got, you can see, GDB for HPC exercise.c in this directory I've created on the work file system. So now we're going to build it, and this is where we can see the programming environment in action. Remember, we don't ever want to be calling the compilers directly. We'll always be calling them via the compiler wrappers. And that means, because this is a C code, we'll be using the CC compiler wrapper. And again, just to state what may be obvious, but to be clear about it, because we've just logged in, we're in the progenv cray programming environment. So that means that CC will be calling the cray C compiler. If we were to switch to, say, progenv GNU, then it would just be calling GCC, but we would still be using the same command here. We would still be using CC. Just for now, we'll just go ahead and we'll use the cray compiler. So we'll do CC. We'll add the G flag to add debugging symbols to the executable. That's important. Without that, whenever we run it through GDB for HPC, it won't be able to tell where it is in the code. I think it will give line numbers, but it won't know the names of variables. It won't know the names of functions. It won't be nearly as easy an exercise debugging it. So you definitely want to add the -G flag, and I'll just call it, and I'll just call the binary, the executable, GDB for HPC exercise as well. So I'll just do that, and that's compiled it, and we've now got GDB for HPC exercise, and we can see that's got executable flags on it, executable permissions. So you can change that name. You can change the executable name to whatever you like. Just remember to change it elsewhere in this exercise as you follow through. So we're going to try and run it through GDB for HPC. That means, first of all, we have to load the module. And if we do module list, I'll try and switch up the commands I use to remind you that you can use any of them, ML or module load. And there's GDB for HPC 4.12.5. Great. So we can start it up. GDB for HPC is all we have to do to launch it. So you can see some blurb here. The main things that are helpful are the help commands you can use. Just quickly see, it's quite a lot, but you can help what is to get information on using all of these. But we want to run our GDB for HPC exercise. Except I did actually name it different here. So, okay, well, I'll show you then. Here it's called GDB exercise, mine is called GDB for HPC exercise. So we want to launch it as a job, and we can just do that inside GDB for HPC with the launch command, and this is going to launch it as a job on a compute node or on multiple compute nodes. Of course, we can't really launch a job without telling Slurm how to launch it, so we need to provide some arguments to Slurm, and we do that through the launcher args option to launch. And inside that, we just put all the options that we would be giving to SBatch. So we want to do it on account TA051, that's our training project account. We want to run on the standard nodes. So we'll just do partition standard. Time can be short. We'll just say 10 minutes. We'll just run it in serial to start with. So tasks per node will be 1. CPUs per task. Task should be 1. And exclusive isn't actually necessary anymore. Export equals all. So this here means that we're going to carry through all of the environment from our current environment through to the job. You wouldn't normally do that in a job script because that might make it that sort of dirties the environment, if you like, in the job with anything you've been doing in your interactive login session. And that can make it difficult sometimes. It might cause things to not execute in the way you're expecting. But here we will be doing it because we're just trying to debug it. We just want to see what happens. We built it, we're going to be changing it, so let's just carry through that environment. Something which can be a little confusing, I think, for some people is the next bit here. So I'm just going to type this in and explain what it means. So here we're saying $myprog, let's just go with the same thing, 1 and /, and it's GDB for HPC exercise. This $myprog is a way for GDB for HPC to refer to this current debug run, so this particular job, if you will. So this is sort of like the job name within GDB for HPC. We could change this to whatever we wanted. We could call it, myprog A. We could call it myprog 1. We could call it a job, which isn't very helpful. We can just call it whatever we like. And later on, if we want to run any GDB for HPC commands referring to a particular job, we can refer to it with this name. So this is sort of like a variable name within GDB for HPC to refer to this particular instance of our this particular instance of the run of the job. And this bit here in the curly brackets and the braces, the 1 is the number of tasks to launch. So we're just running in serial, remember? So we'll just do myprog 1 and let's see what happens. Failed to start launch. So that means something in the launcher args isn't correct. It could be, is there a nodes missing? Possibly. No, it doesn't like it. Okay. Have I missed something there? Account TA051, partition standard, QoS. I didn't provide a QoS. That's the issue. No wonder it didn't launch. Remember yesterday we had the exercise to see what the default QoS was, and we found that the default QoS does not exist. You have to provide one or else. So I'll just go with short here. Remember, we do have the reservation in place. The next job we launch, I'll show you the reservation. Okay, great. Here we go. So we get a couple of lines of output. The MRNet communication network, as I believe it, I think it starts servers on each of the nodes and uses those to communicate between different instances of GDB running in the background. Okay, great. So it started and we've reached an initial breakpoint at line 9 of, and it shows us the source file, gdb8 exercise.c. So it started and now it's paused the execution of gdb for HPC exercise at line 9 of this .c file. At this point, let's quickly go over some of the commands. So I've already mentioned help. List I can show you right now. List basically shows us what's in that source code file at the point that we're currently braked at. So we're at line 9 of this file. So if I run list, and you can also just type L for some of these, you can abbreviate the commands by just typing the first letter. So L, just doing L and pressing enter will do the same thing. List shows us what's at line 9. Here we are. It's an MPI in it. So we're starting up MPI here. And then the next few lines of code after that. Next will take you to the next step in the program. So if I press next, it will take us through to, I think, line 12 here, where it creates a new integer variable called rank. Step will do the same thing. The difference between them is that next will hop over function and subroutine calls, whereas step will take you into them. That I think is useful later on in this exercise. Up can take you through, can take you back up a level. So if you find that you've stepped into a subroutine, but then you want to just get back out of that subroutine and into whatever was calling it, you can use up to do that. And then print var to watch var, where var is the name of a variable, will print the value of the variable at this point we're at now, line 9. And watch var will do the same thing, but it will keep a track on it, and it will let you know when it's changing. Backtrace is also useful. If you find that something is segfaulting, you can go into GDB for HPC, go through to the point where it's doing that, and then get a full stack trace. And of course, something else that's useful is knowing how to exit this. So we've done that. We've done lists, so we can see the code at the point, at our current breakpoint, at our initial breakpoint at line 9 of the main function in GDB for HPC exercise.c. And then we can keep on doing this. I'll show you if I just press L, we then get the next few lines, and L again gives us the next few lines. But let's continue execution. So if we do next, this will go. So something you need to be aware of is to not just do next, next, next. You need to give it a second to then get the message that it's reached a new breakpoint. So this is now telling you that main has now stopped at line 13 of this source code file. And if we do list again, we'll see we're actually at an MPI com rank. That's the next thing to exercise. This is the next point that we've stopped at. So we're finding out what is the rank of this MPI task and storing it into rank. So let's do, yes, so something else you can do is you can do next and then give it n with where that's a number to skip ahead however many lines you like. I'm going to just do another next without that. And if we do list, so at this point, we're at this point in the script, so we can see it's creating an integer called count, and it's going to assign to it the value of our rank +1. So here what we can do is we can do print count, and we'll see it has some number and it's garbage because it hasn't been initialized yet. So it's just 2,104,192. That's probably not our rank, but let's do another next. So we'll actually move past this. We'll actually move past line 15. That will have taken place. Where are we now? We're at line 17, so we're about to go into these ifs and else ifs here. Let's print count again. Now it's 1, which is what we would expect. This is a serial process, although it is starting MPI, so that means that our one task will have a rank of 0, and so count, which is set equal to rank plus 1, is equal to 1. So now we've got a little exercise here. What happens if you keep using next in the list? I'm hoping everyone's following along with this. I'll give 2 minutes for people to have a go at this, and then we'll see what the solution is and we'll try it out here on the screen. So at about 28 minutes past, we'll take a look at the solution. I would actually just take this opportunity just to say, if you are trying this and do run into issues, just as yesterday, please do let us know so we can give you a hand. Okay, so you've hopefully had the chance now to just keep on stepping through the code and checking out what the code is with the list. So let's find out what happens. So this says that the program will move from executable line to line until we get to line 18, which is actually only just a little bit ahead, at which point we'll exit due to an Mpi error. So let's try that out. Let's do next. Okay, here we are. And that is indeed an Mpi error. In fact, it's telling us that the rank has value 1, must be non-negative, must be less than 1. So something interesting is happening. Of course, the reason is that we're running with one task, and you can't really send from one task to another task if you only have one of them. So let's quit GDB for EPCC. And let's start it up again. Could have killed the job and then just done it again without quitting GDB for EPCC, but we see how to do that in a second. I'll just copy this command in this time. And for HPC. So this time we're going to use 2 tasks instead. And I'll also just quickly use the reservation to remind you how to use that, just in case we do find that short takes time. So we want to just change the QoS to reservation and set the reservation to the value which put on the Etherpad. That runs until 4 o'clock this afternoon. And we want the second day, and that should do it. You can see me going back through the command and changing it to ruin the formatting a little. So it's doing just the same as before, but now we've got 2 tasks and we're running on one of the nodes in our reservation. Okay, and we can see the command here has changed, so the output here has changed very slightly. Let's find, so up here, if you notice, we're being told all the time, my prog, curly brackets 0. So that means this is the 0th MPI task reporting that it's at line 18, and this is the rest of the code. Down here, after we've launched our parallel job with 2 MPI tasks, it's now telling us that my prog 0.1 has reached the initial breakpoints. That means both processes 0 and 1 have reached this initial breakpoint. So we saw that the code was trying to send count from one process to another. So here's another quick exercise. I'll give you another 2 minutes here. So we'll stop at let's see, we'll stop at 10:34 here and see what we can do. The code seems to be trying to send count, so we're going to try watching count and seeing how it changes as the code executes. So I'll just give a couple of minutes there for you to see what happens. So you just want to be doing something like watch count and then next. Carry on doing that. See what you can find out. Okay, it's been about a couple of minutes, so hopefully you've come to your solutions. Does anyone have any idea just now, if anyone wants to shout out what they think the problem might be before I click on the solution here? Or else type in the chat. If there are no takers, okay, let's take a look at the solution then. So if we actually do it, well, we can see that the problem is in the MPI still. So if I start doing next list, I can just keep on moving through. So we can see here that the variable count has been set. So that's telling us right now. So if I just do print count, I'll see that it's 1 for process 0 and 2 for process 1. Okay, great. Next, line 18 and 21. So that means they're now on different lines of the code. Process 0 is sending. Process 1 is receiving. Now, what I'm being told after doing next, this is the important point here. Process 0 has moved on to line 19. So process 0 has reached this barrier, MPI barrier. Process 1 has not. Process 1 seems to be stuck here at this MPI receive. So something's gone wrong there. And you can possibly see already what the issue is. Let's open up the code. So we want to quit here, and then you can use whichever text editor you like, of course. Emacs and Nano are, I think, both available here. I'm just going to use Vim because that's my code of my text editor of choice. So let's open that C file. So the issue here is that we've got an MPI send, and this seems to be executing fine. It's sending to process 1. That's perfect, okay, with a tag of 0. But this one is also receiving from 1, and it's receiving with a tag of 1. So we just need to change some bits here. So I say that let's just change this to say that we're going to receive from process 0, and we'll just set the tag to be 1 because it's got to be something. So if I try to do this, let's do that. So we've hopefully fixed it so that the two processes are now talking with one another. So hopefully now process 1 can actually receive that message. Let's try to rebuild it and rerun it and see what happens this time. So there we are. We've just done the build again with cc-g. Let's go back into GDB for HPC. Do I have the, no, I don't. That's the one from before. Let's just copy this again. And again, I'll just quickly change it to run on the reservation. So we just want to change the QoS to reservation and set the reservation equals to, oh, I shouldn't have done that. Forget that. This might be quicker. And I'll just grab the reservation code from the Etherpad once more. And let's run that. Oh, and I didn't change that to GDB for HPC. Okay. Okay, so that's launching. Again, we're going to watch the variable count. And then we're going to start stepping through the program. So let's watch count. Then we'll do next, next, next. They're both at line 17. Okay. And where are we now? So now we're at line 18. So this is the one which previously wouldn't work. So hopefully we fixed that. We can see process 1 is now at that MPI receive. Let's see if we can get process 1 to progress past that point. And yes, it has. And it's also telling us that count has now changed. So let's print count and see what's happened. Print count, no context. Wow, what's that mean? Let's quickly skip past that, see if it shows up again. Next. Aha, it's still running. So now we're finding that there is actually still a problem here. And I think if I try to do print count, it will still, yes, so there is still an issue happening here. So we've got one more thing to fix. This is a slightly different problem we're looking at now. It's not an MPI problem. So we can't quite see what's happening. So we actually need to stop this again. So we'll do release $myprog. We can then launch it again, but something's happening after it. And if you take a look at the code, you'll see that it goes into a function within the code. And I think what we're doing here is we're moving past that. So we need to now step into it rather than just next, because next, remember, doesn't take you into any functions or subroutines. So we need to step into that function to find the point where process 0 now is getting stuck. So let's launch again. This time, so we've stopped the first run, myprog. We're now going to do a new run, but we need to give it a different name. So let's just call it my new prog. And again, it's going to have 2 tasks. And we'll start that. And what we can do once that's gone is I'll give 3 minutes, because now this is a little bit further through the code. So at 10:46, say, we'll see if you can find where the issue is in sun even. So this is where this is the name of the function that process 0 is going into, where it's hanging up here. So I'll give you 3 minutes, and you should go through to the point where about the MPI happens. Maybe you can just go past that, and then try stepping instead. Try stepping into it and see if you can find what's happening in sum even. Okay, yeah, and we'll come back to that at 10:46. Okay, I hope you've had a chance to try that out. I've just got through to the point where things start to go wrong here on my session. So, so process 0 has got past its own communication. It's now at the point where it's about to see if its rank is equal to 1. It isn't, so it'll skip that, and then it'll move on to doing sum even, which you can see just here in the code only happens if rank equals 0. Process 1 is about to check if rank equals 0, no, and so it's going to skip past that to the MPI finalize. So if I try doing step now rather than next, we'll find that the lines have changed again. Let's see where they are. So process 1, yep, is waiting at MPI finalize now. Well, process 0 is about to head in here to sum even. Let's try a step again. Now, so process 1 you can see now is waiting at MPI finalize. Process 0 is now moving on to line 28. So yeah, it's right about to, we get a message here. The rank 1 process is running. Process 0 is now on an MPI barrier for doing this. So step again. It's now on line 43. Oops, it's on, yes, so on 28. So yes, so at this point it was going into sum even. Now it's inside sum even. We're told it's on line 43, which is here. We're setting a variable called result to 0. Let's step through it again. It's now on line 45. While I is less than or equal to max, we're going to be looping. And you can maybe see the issue right now. Let's keep on stepping just for a little bit. List. So we're on line 46 now. If I mod 2 is equal to 0, okay, then we're going to add I to result and increment I. Let's carry on stepping on line 47, where we're doing that result plus equal to I. Let's do some more. Now on line 48, where we increment it. Okay, sure. You can see that line 48, I is being plus plussed. Hopefully you can see what the issue is here. I'll carry on stepping just to show you what's happening. We've gone back to line 45 while I is less than or equal to max. Step again, we're at line 46. But now we'll actually see the issue happening. We've gone back to line 45. So we've gone into this if statement once, we've incremented I, but the second time through, we've just gone to the if and we've gone, nope, that isn't true. I mod 2 is not equal to 0, so we're just looping. If we carry on doing step again and again, we'll go from 46 to 45 to 46 to 45 over and over. So you can hopefully see what the problem is. So the I++ is at the wrong place. So if we quit, that'll kill the job and then bring us back out to our terminal. We can do vim gdb for hpc exercise.c, and we can come down here into sum even, and this is the place where we were going wrong. So we're starting off at 0, starting to loop. First time we go into the if statement, we increment I to 1, but then in further loops, that's not going to be the case. We aren't ever going to come back in here because and that means we won't be incrementing I either. So that increment is not going to happen, and we're never going to trigger the if, which is able to move it into a state where it would be accepted. So we'll get rid of it there, and we'll just add it here. And now it will increment it even when imod2 is not equal to 0, and that way it will keep on increasing, and we'll just add the even values to the result before exiting once it reaches max. So that should now be our code fixed. Because we are getting on a little bit, I won't show you that running, so I hope you'll trust me now that that's the code fixed. So we use GDB for HPC to find and solve an MPI issue when we saw that one of the tasks was failing to move past its MPI send. Sorry, MPI receive rather. And when the other task was looping forever because it wasn't able to increment the variable it was using to exit properly. So I've showed that's one way to run GDB for HPC. Something you can do is you can attach it to a job which is already running. So this can be handy if you're running a job and you find that it's hanging. So you can then start GDB for HPC up and attach to that job to understand the state it's in at the moment and hopefully see why it's got to that point. Something else you can do, which is quite nice, I think, for debugging if the system is a little busier, is you can salloc to start an interactive job, and then you can launch from within GDB for HPC directly onto that. So you don't have to then specify the launcher args options. So if there's something if there's some code which you're very rapidly changing and don't want to have to wait for the job to start every time, if you're finding that you need to do that, you can salloc to start one job and then repeatedly launch with GDB for HPC into that job. Okay, so that finishes our little section on getting going with debugging. I'll move now onto profiling tools. We don't have really an exercise here, but we do have an example. I'll just sort of go through and show you the kind of outputs you can get with this. So there are a few different tools again provided by Cray for profiling. Oh, I think how to connect the running job with GDB. Yeah, so we'll be running a little bit out of time here. I hope you don't mind if we go on a little further. If you would like, we do have the session this afternoon. We could go over it then, if you would like. Because this afternoon we have a sort of let's work on our own problems type session. So I'd be happy then to go over how to do it. That might be a better way to keep on track with time. Does that sound okay to you, Angeles? Okay, no, sure, absolutely. The time's there. Okay, so we'll look this afternoon then at how to attach GDB to a running job. I might have to see if I can quickly set up a job which is going to segfaults, and then I can demonstrate that to you. Okay, yeah, so we'll carry on with profiling for now, and this afternoon we'll look at attaching to a running job with GDB for HPC. Okay, so back to profiling for now then. We'll go over CrayPat and CrayPat Lite, what we're going to be talking about just now. So these, so CrayPat Lite is a sort of very simple to use profiling tool. You basically get it loaded, and you will generate executables which are already instrumented for profiling jobs, and you can just run those and get sort of generally useful information. CRAPAT works similarly, but is more full-featured, offers a lot more options on the type of information you'll be gathering during execution. We'll be looking at both of those in just a second. Reveal is there, has performance analysis and code optimization. PAPI are support packages, so these give you access to performance counters in the hardware. And ARCHER2, I will show again, maybe if there's time at the very end of this, or perhaps this afternoon again, if we run out of time, offers a GUI to essentially take a look at the information generated from the other tools. So we're going to use CRAPAT Lite just now. So I'll, in my terminal, create a new directory, which I'll call profiling example. And I'm going to grab a tar.gz from the website again, which we've now got, and I can extract that into a directory called nbody, a directory called nbodypar. Now we want to have the perf tools Lite module loaded. So what I'll do is I'll do module load perf tools Lite. So this is pat Lite, CRAPAT Lite that we're using, but the module is perf tools Lite, so performance tools Lite, if you like. And inside here we've got a few C source files, we've got a header file, we have a make file, and a run.slurm script. So what we can do is let's just try making it. So we get the usual output from make here that we might expect. We can see it's using the C compiler wrapper. Great, we remember should always be doing that. But then at the bottom we get some extra information. Info creating the perf tools instrumented executable nbody parallel.exe Lite samples. Okay. So as it's telling us, we've now got an executable which has been instrumented by CRAPAT Lite. We've also got a run script, a batch script called run.slurm. Let's just quickly change this so it will actually run. Again, I'll change this to run on the reservation. So if you're doing this also, I would say do the same, and that way you're guaranteed essentially that your job will run straight away on our reservation. Okay, that should be good. So we're going to just be running there, and we're doing srun CPU bind cores nbody parallel.exe, and then these are just some arguments to the nbody code. We don't really need to worry about that. We just want to see how does it run. So I'll save that and quit, and then we can sbatch that run.slurm file. And if I sq myself, I will hopefully see it running. Yes, it's running on NID 001256. And it's now, there we go. So I wasn't able to show you this yesterday because there weren't any jobs completing, but this status, CG, means completing. So the job's finished, essentially. The execution has finished. Slurm is now just doing tidy up operations, making sure everything's good for the next job that comes along. And if I now sq again, it's gone and it's finished. So that's run. We've got a slurm out.txt file. This is some output from the job itself. So this is the n-body simulation output, but we've also got some output at the top to let us know that CRAPAT is running. And then what we've got after that, and I'll just make my terminal a bit wider. Actually, let me do less slurm.out. Oops. There we go. And what we've now got is a lot of extra information, which is the output from CRAPAT Lite, which gives us our profiling information. We can see here we're getting the number, we're getting a profile, a sampling profile by function. It's breaking it down into categories, so it's telling us that for this example, we're getting that 83.2% of the samples were found in compute forces multiset, which is a user function. Then only 15.3% of the total were found in MPI functions, but it's breaking them down. You can see there's an MPI file open, a write all, receive, send, receive, and there was a very small amount of time spent in a square root call. And then if we go on further, we get another table, which is now breaking it down even further. So it's telling us which lines it's finding samples are being found, and so we're seeing how much time is being spent on certain lines in the code. And so we can see here that this parallel.c source file, a lot of time is being spent in particular in lines 148, 149, 150, 151. Some smaller amounts of time further a bit higher up in the file. And then again, we're just getting some generic information about MPI there. Then we're getting memory bandwidth by the different NUMA nodes, if this is of use, and even power consumption. So there's a decent amount of information there. There's a good chance that the information from CRAPAT Lite will be enough for you if you want to do profiling. If you just want to sort of have an initial pass over your code, see if there are any obvious hotspots for time being spent, or I guess more important, time being wasted where it doesn't need to be. It may be that that will give you an initial way to get going with that. Yes, but if you do need more information, that's when we would go on to the full CRAPAT rather than the PAT Lite. So, well, the commands here show you unloading and loading. I'm just going to show you doing a module swap. Remember, that's an alternative way to do this. We can do module swap perf tools Lite, and let's load perf tools instead. So we're swapping out the Lite version for the full version. And if I do ML, we'll see we've got perf tools loaded. We need to start again. So let's make that clean, and then we'll make once more. This time we didn't get a message telling us that the executable had been instrumented. That's because only perf-tools Lite does the automatic instrumentation. So what we need to do now is a separate step to do that, and we use a tool called pat build. So we've created nbody parallel.exe. You can see that here if we do an ls. There it is. That's the new one which we just built now. But we now need to pat build that that nbody parallel dot. That's because it's a hyphen and not. There we go. And now we'll see. We will see this. This is the new executable that we want to use for our profiling run. So they come out with this slightly odd format. So first of all, got the name of the instrumented executable, which is just nbodyparallel.exe. Then we get plus pat, and then the process ID. No, wait, sorry. This happens after. Yes, so no, sorry, I'm going completely wrong here. This is the new executable. nbodyparallel.exe plus pat is our executable. And if I do ls-l, we'll see that that's the new one. If I bring it over, this is the runtime directory, yes. So this contains output files. So nbodyparallel.exe plus pat is our new instrumented executable. So we want to actually modify our run.slurm just now, and we just want to add a plus pat to the end of it. And now when we run, we'll be doing that. So if I now do sbatch run.slurm, and I'm now running that new instrumented executable. Okay, and there we go, it's running, it's completing, it's finished. And we should now have the new directory, which is this one here. So that's the name of the executable, and then it's got the process ID it had when it's run. This was the node ID it's run on, and we could have possibly, yes, here we go. So we can see here it's run on node ID 001256. Here's 1256, and S here means it was a sampling run rather than a traced run. To check what that actually means, because if we take a look now at slurm.out, we'll see we've only got the outputs from the run, from the executable itself. We don't have all of the tracing information, so all of the sampling information. We don't have a report. So we now run pat report, and we give it the name of that directory as an argument, and press enter. And it tells us a whole lot of stuff. So what we can do is we can pipe this to less to read it, or we could redirect it with a chevron in the shell. But we can see here we've got a lot of the same information as before. We've actually got, I think, quite a bit. I think the tables do go on further, but we can choose as well. We can see a profile report by function. So we can do a pat report -v -o. Oops. And then we give it the SAMP profile. This is just an option on the name of the directory. And then I'll pipe that to less so that it doesn't just fill up the screen. And we now get, oops, I've gone too far. And it now gives us just the single table, just the profile by function. And we can see the same information that we got before. We can add a SAMP profile, we just add plus src here, and then we know it will be instead showing us the time spent in each line as we did before, as we saw before. And callers plus source, so this is a little different. That's it, yes. So now what it's doing is it's telling us how much time is being spent in given lines and where they're being called from. So we're seeing specifically here that the time is being spent, say, in this MPI file write all. 4.3% of the overall time was being spent doing this MPI file write all, and that was being called from this function in this file at this line, which was being called in this function in this file at this line, which was being called from main at line 81. Or, you know, the big user of time, and this compute forces multiset was being called from run parallel problem and parallel.c at line 81, which was being called from main at line 81. So this is, again, this is a good way if you need to work out where specific calls to time wasters are coming from. So we're running a little bit over, but I'd like to get this out of the way because the later sessions don't take quite as long. So something which we do get, so we've got this directory here, this new run directory. And if I quickly ls inside it, we'll see that there are two directories and a couple of files inside it. What's important really is this one here. There's this buildoptions.apa file. So this APA stands for Automatic Program Analysis. So from the first run, which was a sampled run, which means that the program was executing, and every so often it pings the program to say, where are you, which line are you on, essentially. And that's how it builds the profile of where time is being spent. But from that, it produces a buildoptions.apa file. And this helps it to do a targeted trace run, where rather than just pinging it every so often, as you would in a sampled profile, it will actually accurately track the time being spent in different functions and different subroutines. You don't really want to do that for everything, because spending the time to work out how much time you're taking uses time itself. You know, it's sort of the whole you can't observe something without changing what you're observing problem. But if you do the sampled run first and then do a new build based on this APA file, it will trace only the functions which it thinks are worth tracing. So it sort of automatically works out what it thinks is worth taking a look at, what is worth spending time doing that tracing on. So what we can do now is we can do a pat build, and we'll pass as an option that APA file. So if I cp that and then do build APA, it will now produce a new executable with plus APA at the end. And if I do vim run.slurm and just change that to APA, it will now run the tracing experiment instead. So if I sbatch that run.slurm and do sq uwlta051, I can see there's my job running again, still running. It will be longer than the other run because it is now tracing some of the functions. And then finally, now it's completed, we'll have a new run, and we can see the name of the executable in this output directory has changed. This is our new output directory. There's the name of the executable, which includes the APA. There's the process ID that the Mbody executable had while it was running. It's again ran on node 1256, and it's got a T at the end, which shows that this was a tracing experiment rather than a sampling experiment. And we can now do a pat report on that. And let's just copy the directory name in again, and I'll pipe it to less again. And this time we'll get much more accurate information about the functions that it's actually timing. There's a lot of information in here. This is where I think the Cray documentation is really needed. If you know what you're looking for, you can find out how to find that information and then generate it from pat reports. And yes, and now we can also get the hardware counter information. If I do -v-o profile plus HWPC, so asking for the hardware performance counters now. And here we go. We can see now more information about how many cache prefetch hits there were, how many requests there were made, how many were found from off core, how many were found from memory, write memory traffic, all this information which wasn't available before. More information about MPI. Again, there is a lot of information there if you want it, if it's of interest to you, when you're trying to improve your code's performance. Finally, I'll just do this very quickly. I'm going to log back in. I think I need Y for it to work for me. Let me see if I can do this quickly. I'd like to just quickly show you Apprentice2 running, because I think this is quite a nice way of just visualizing the results from your profiling runs. Oops, is that not it? I've got too many accounts now, and finding the right password for my account is sometimes tricky. There we go. Okay, great. So let's go to work. TA051, TA051, WLTA051, and I'll go into my profiling example, then into nbody.par. Okay, so there is my output, and I think I don't think you need a module loaded for Apprentice2. I think it's included as anyway. Let me see if this works. And you just do this, and hopefully I'm on Mac and my X-Quartz hasn't started, so I'll probably have to wait a second for that to appear. Yep, there it comes. Let's see. I'll move over here and then drag the window across so you can see it. Okay, here we go. So you'll need to connect to ARCHER2 with X forwarding enabled. But if you do that, you do get this starting up. So this is, and because it's a GUI and ARCHER2 isn't really built for that, it can be a little bit laggy, but I think it's still nice to just be able to take a look at this. That may not do the job. If I click on function region profile, here we go. So now we're seeing there was 92.8% of calls were made to MPI send receive. 3% of calls were made to MPI file write all, and 4.2 to other calls. In terms of time, we spent most of it actually in main and not very much in wait a second, let's go for a flame pot. Okay, and now we can yeah, so you can just choose different ways to plot your information over here. And now we can see the activity over the different processing elements. So processing elements just means different MPI tasks here. So we can see process 0 spent very little time synchronizing compared to everything else, but did more time doing data transfer. And the amount of time spent oh wait, sorry, that's a read actually, is it? Two colors are a little tricky. Yes, that's data transfer. Yes, it is. So process 0 is telling us spent more time than the other processes doing data transfer. So there's some imbalance there. At least we can see process 0 is spending more time doing data transfer and less time synchronizing. The others are spending less time doing data transfer and more time synchronizing. So it might be you want to balance that out a little between them. And you can see other pieces of information here. You can get cool plots showing you which functions are calling which, how much time was spent in them. I think this is a decent way to get a good overview of what your code is actually doing and where it's spending its time doing what. Okay, so we've overrun a bit there, but the later sessions won't take as long, so I think we'll be able to make up time. So yeah, there is again, this is an introduction. We can't cover all the details of everything, but I would say definitely take a look at the ARCHER2 documentation and the Cray docs as well for this, because of course they're the people who wrote this software. If you find these interesting and want to know more, as I say, we will try later on I'll try and find a code I can get to crash mid-run, and then I can see if I can show you how to attach it. We'll do that in this afternoon's session. But for now, that's us done with debugging and profiling. This says a 15-minute break, and I think we should take 15 minutes. So we can, when will we come back? We'll come back at 11:40, and we'll move on to how to be a good ARCHER2 citizen. Okay, I'll see you in 15 minutes then. Hi everyone, welcome back. So we've got another session now on how to be a good ARCHER2 citizen. Just some more general information about how to make things essentially as pleasant and smooth as possible for both you and anyone else on ARCHER2, all of the users collectively. This shouldn't be too long a session, same for the one afterwards, so I think we'll make up time from going a bit overly long on the debugging and profiling session. So let's get started. Okay. Yes, so as I say, this is about being a responsible user, looking after your data, being considerate of the other users on the system. And of course, if everyone does this, then that means everyone's sort of looking out for you as well. And it just makes using the system much more, as I say, much more pleasant an experience. So there are a few things to think about. Something which sometimes people aren't aware of are that there are things that they shouldn't be doing on the login nodes. So the important thing to consider here, the important point, is that they're a shared resource. I mean, the cluster as a whole is, but when you're running on individual compute nodes, those nodes are for your use and your use alone. So you can do whatever with those resources is required for you to get your jobs to run. That isn't the same for the login nodes, where there are potentially very many users logged in at the same time. We have the multiple login nodes. We try to make sure that the load of users is fairly even between them, but there will still at points be many people logged on to each individual login node. They'll all be logging on, they'll be creating and editing files, building software, possibly running things like ARCHER2 we saw just there, so there might be GUI applications running. So this does create a load on them just from the sheer number potentially of users on there. So, so what we ask is that people don't try to do any real heavy, I will say, computational work on there. It won't run in any performance way, so you will probably not have a great time trying to do that. And also, very notably, parallel tasks can't be launched on there. If you try and do an S run, that will just try and launch it onto the compute nodes where it should be. And if you try and use something else like Mpi run or Mpi exec, they don't actually exist, so they can't be used anyway. So you can't run parallel tasks, but you shouldn't run any long CPU heavy tasks anyway. We say here quick tests are generally fine, so something which maybe just lasts a couple of minutes, literally just a couple of minutes, just to see if your serial code will even start. But you should really try and quit it as soon as you're happy with it, and then go to a compute node to do proper testing. If you use too much of anything, then other users will be affected. Things will run slowly, and all of a sudden, what should be fairly simple working on there may become a bit more of a trying task for them, and they won't be quite as happy. And that goes for everyone. So we ask that no one at all does this, to make sure that you, in turn, have a nice time doing whatever you need to do on the login nodes. So what you can always do is, if you do accidentally start something, and it does happen, everyone's human, everyone makes mistakes. So sometimes you will find that you do accidentally start something you didn't mean to. You can normally just just press Control-C to quit it, and that's fine. It's killed. Problem solved. Sometimes it is possible through if you're running bash scripts which nest with one another or start new shells, you might find that you do accidentally start a background task or the like, and or run something through screen which becomes detached, and you can't get back to it to stop it from running. What you should always be able to do is to use the command psux to list any processes that you're running on a given login node, and see how much CPU and memory they're using. And once you've got the process ID, which is just a number, we saw some of the process IDs for the jobs in those performance tests we were just running before the break. You can use kill with that process ID to end them. Something important to note is that here, the processes that you're running on a login node. So if you're logged into ln, well, here I am at the moment still. Let me just here I am at the moment. I'm on ln03. So if I do psux, here's everything I have. This is just me basically on the system. I'm running bash. I'm running psux. I've got SSH going. Nothing unusual, but this is only showing me what I have running on this login node, ln03. If I had anything on ln04, I would have to log out and then log back in until I got onto ln04, and then run psux to check there. So this is a short exercise here. It will only take 3 minutes to do this because I think it's very simple. I've got 5 examples of commands. You can try and deduce what they're doing from the names. From those names, it's just which ones do you think would probably be fine to run on the login nodes? We'll just take 3 minutes now to take a look at them, see what you think, and then we'll go through them. But yeah, this should be fairly simple. So we'll come back at 11:49 to talk about these. Hey, hi again, everyone. Hopefully you've had a chance to just look through those 5 examples. So let's try and see if we can maybe do this with a little poll. Let's say, so would it be okay to run example 1? Let's just do a poll on this. So you can just say yes if you think it would be fine to run Python physics_sim.py. No if you think it wouldn't be okay to run Python physics_sim.py. Okay, I can see the responses are going pretty heavily in one direction. Won't take too long there, because this is a fairly simple exercise. Okay, this is interesting. Okay, I'll stop it there. So 5 people responded to that. 1 person said yes, 4 people said no. So Python physics_sim.py does sound like it might be intensive in some way. So actually, we probably wouldn't want to do that. I say probably. If you were going to run it just to maybe check that it can start okay and it can read, say, input files without crashing out, that would be okay because you would be just starting it, checking it for 30 seconds, a minute to make sure it's okay, and then quitting it again. That would be okay. But if you were going to let it run for any length of time, doing what sounds like intensive work, then that definitely would not be okay. So it's probably no, but in the very specific those very specific circumstances of just quickly starting it, making sure it's okay, stopping it, it would be okay. Let's do the same for question 2. So, which would be okay to run on login? Make. Do you think make would be something reasonable to run on a login node? Sorry, I think the quiz was frozen just for a second there. The question was frozen. I've just fixed that. If you want to say yes or no to running make on a login node. Okay, everyone at that point, I've ended. There are 3 people who said yes, no one said no. That's fine. Yep. Make is probably perfectly fine to run on login node. I'd say the vast majority of people do run builds on the login nodes. Sometimes you might find that it's easier to run a build on a compute node, purely because some builds are very long, and you may just want to be able to start a build and go home for the evening and let it run. And of course, you'd be using resources to do that, but most people, I think, just go ahead and run a make on a login node, and yet that's perfectly fine. Okay, what now about create directories.sh? These are skewing one way again. Okay, let's stop that. 4 people responded. Everyone said yes. Yeah, absolutely. That sounds absolutely perfect for a login node. It sounds like you're just doing some setup perhaps ahead of a run. You're just creating directories and then you'll be putting data in there. That's perfectly fine for a login node. Something a little different now. 4, molecular dynamics 2. Okay. Okay, we've had 4 responses. Again, everyone said no, and again, you're completely correct. This is probably not okay. This does sound intensive. It sounds like it's going for a full-on simulation of well, molecular dynamics, and that's probably going to be pretty intensive. So we wouldn't want that to run on the login node, unless you really were just doing a serial startup just to check it's okay and then stopping it immediately. But probably, from the sound of it, this is not going to be appropriate. Finally, let's just quickly do 5 and then we can move on. Let's check again. So who thinks that doing a tar xzf r3.3.0.tar.gz would be okay? So just in case you are not sure of these flags, xzf means that it's going to extract a gzipped file. So it's taking this tar.gz and it's going to extract it onto the file system. Okay, people maybe aren't as sure here. I'll stop the poll there. We only had 3 people respond there. 2 people said they thought it would be fine. 1 person said they thought it maybe wouldn't be fine. This probably would be perfectly all right. Doing a tar xzf is just taking a tar file, taking the contents and putting them on the file system. So this shouldn't be computationally intensive. It should just be, this is probably done very, very commonly by people just moving data into position for a run. Possibly, if you're building code, you might be obtaining it in a tar.gz file. So you would just be getting the code out from that archive ready to build it. This is very common. It's not intensive. It'll take a few seconds at most, probably, depending on how big the file is. But it's a one-time thing. Get the data out of it, and it's done. So this should be fine to run on a login node. If I just, well, we can just drop down the solutions here. Yeah, so the first one, probably going to be a simulation. You can build on login, but you might want to go for a compute node if it will take a long time. Shell script creating directories sounds fine. Molecular dynamics sounds like it'd be a simulation again, so that should go on compute nodes. And expanding small archives would usually be fine. Extracting large data, it says here, extracting large data archives may be better suited to running on a data analysis node. I think kind of the same as the build. Oh, I would probably only do that if it took a very long time. Probably the vast majority of archives you'd be perfectly fine to extract on a login node. Yes, and then a note here, this is important. If you do experience issues, please don't do anything yourselves, just send in a query to the ARCHER2 service desk. If you suspect, if you are on a login node and you see perhaps people doing things that you maybe think they shouldn't, please just let us know about it and we can deal with it appropriately. So what is the time? So what do you mean? There isn't a time limit. There isn't a hard time limit. It's just if you mean the time for number 5, to be polite. So really, if you were doing something like a build, you would probably you could run it for any length of time. when to move to a compute node is more for your benefit. The thing is, create lots of individual tasks. So it will be building this piece of code, then that piece of code, then that piece of code. So you can run that, and the people will still be able to do their own work around it. It's if you're running something big and long, like Python physics sim.py or molecular dynamics 2, which are going to be single tasks that will run a long time, that's when you wouldn't really want to go more than just a few minutes. If you were building something or creating directories or extracting something, it could potentially, you could run that as long as necessary. This is the kind of work that is meant to be performed on the login nodes. So if it is something that took a long time, you could choose yourself to do it on a compute node or a data analysis node, just so that you can do it as a job and you can forget about it and come back to it and find it completed later on. But there wouldn't be any real requirements for you to do that. Yeah, so as I say, the make is really up to you, because the login nodes are meant to be used for doing things like make. So so it may be that if you do have, 2 hours or more to wait, you can just go onto a login node, do other work, and then 2 hours later it's done. If it really does take a long time, and some pieces of software really do take a long time to build, I think, is it Quantum Espresso, I think? GCC, I know when I've built GCC on another cluster we had before, that can take a good few hours. So I would do that on a compute node just because it's much simpler. You can create it as a job. It, of course, doesn't have to be parallel. You don't have to S run it or anything. You can just tell it how many processes to use in the make, and you just send it in as a job and forget about it until it's done. And that's purely for your own convenience, really. So for you running a make, it would really just come down to how long are you prepared to put up with. The really important ones here are number 1 and number 3, because number 4, because those sound like they're going to be running simulations, and those will be single long-lived tasks using lots of CPU and memory, and that's not appropriate for a login node. Of course, there are even worse things. Please don't say mine cryptocurrency on the login nodes. That's the sort of thing where if you spot something like that happening, please send in an email to the service desk so we can sort that out. So yeah, of course, what you're doing should be related to your, to the work you need to do, and not, anything else. Okay, I think we can move on from that. So other things to be aware of are to not share your login credentials. So we, but because I think I mentioned yesterday, there was the security incident, that happened all around the world back in summer 2 years ago. And so we're trying to really stay security conscious here. So we ask that please no one shares their login credentials. So please don't share accounts with anyone else. And if we ever find or suspect that that might be happening, we have to ask the people to please stop and to reset their details so that the other person can't share it anymore. If you think, if multiple people should be working on the system, then just get them an account of their own and share data or source code through the shared directories. Something else we also don't allow is for using another ARCHER2 account from your account. So, so some people sort of SSH within from one to the other, as that can potentially allow you to capture credentials for the other account. And again, those credentials should be kept should be kept secure. So this is not going to allow that. More directly for your own benefit is to remember that jobs on ARCHER2 are being charged. So what are very simple mistakes in scripts or in initial conditions or setups for runs can end up costing you, can end up wasting a large amount of your budget if you aren't careful. So the example here is imagine a job script with a mistake. So it sits doing nothing for 24 hours on 1,000 cores, or one where you've requested 2,000 cores by mistake and only use 100 of them. You will be wasting a lot of the budget that you've been given by doing that. So please do test beforehand. Some people write scripts, so they will write batch scripts to automate job submission. So they maybe have a script which will create multiple job scripts for them and then send them off into the queue. If the script creating the job scripts is creating incorrect job scripts, then all of a sudden you've maybe sent off, you've possibly submitted 50 jobs which will sit doing nothing for 24 hours on 1,000 cores. That could possibly ruin your budget for you. So you definitely do not want to get into a spot where you do that. It wastes your budget. It stops other people from using those nodes as well. And even if you don't waste resources, if say, if you make a mistake in the part of the script to run the job, maybe you need to export an environment variable for your application to run, and you forget to do that. So that would mean that it would crash. What might happen is you might say, okay, I'm going to run a 1024 node job, send it into the queue, wait, with anticipation for 5 days, looking forward to getting the results, and then it finally starts because, let's say, over those 5 days, the queue's been very busy, and then it starts, and then it crashes out almost immediately. That will be very annoying for you. So what you should really do is before submitting any large job, before submitting a large run of jobs, try just one first of all to make sure that it works as expected. And before submitting a very large or a very long job, which would probably take longer to get through the queue, submit something short and truncated to make sure that it will start and run as expected first. This is to make sure you don't waste time, you don't waste resources, because if you do get into the spot where one of these events happens, you would probably be quite understandably a little annoyed with it. So this is just really to make sure that you don't waste your own time, that you don't get into that spot. Backup we mentioned briefly yesterday. The home file systems are backed up, but work isn't. And so home is only backed up for disaster recovery. So this means we can get back the whole file system if something takes the whole thing out, takes out the file system as a whole. So that means we can't really go and get back a directory that you delete by accident on home. So this means that the data is really your responsibility. If you have anything important on there, you have to make sure that you have it backed up. Oh, Andy said that is not correct. Has that been updated then, Andy? All users can access backups. Oh, that must have changed then. I wasn't aware of that. Okay. Oh, wait, is that the thing with the hidden files, which don't show up under ls-a? Oh, okay, great. Thanks, Andy. Okay, here's something that needs to be changed then. Okay, thanks, Andy. This is good to know. Presumably, this is still just on the home file system, right? Ah, okay, great. Yes, so it is. Ah, okay. Okay, so Andy's just put a link there. Ah, okay, so this has happened more recently and I wasn't aware of this. So yes, no, I think so there's .snapshot. Okay. Okay, great. So there are backups available on home at least, which you can get to by going to these .snapshot directories. Okay, so full backups taken weekly for each of the past 2 weeks, daily for each of the past 2 days, and hourly for each of the last 6 hours. You can access the snapshots at slash home1.snapshot, which are the file systems you have your home directories on. So this means, so if I go to my home directory, we can do read link -f dot, and I can see the time on /home2 here. So if I go to cd /home2, then there'll be a .snapshot directory. Oh yes, perfect, there it is. Okay, great. So here are the backups then. Okay, so this is then incorrect. So if you have anything on home, you can actually get it back. So we can see this goes back to the 30th. Okay, so yeah. Okay, no, so the last one is the 23rd of January. So we can go into here and we would then be able to presumably see 23. Perfect. And there's home. Okay, yeah. So so you can access those there. So snapshots are available then for the past wee bit. Still, if you remember, home file system is nowhere near as large as the work file systems. So chances are your data will still be living on work. So the point still stands that if you have some valuable data that you've generated on work, that will probably not fit if you have a lot of it on home anyway, then you should still take care to move that away to backups of your own. So source code you can of course also store on GitHub or GitLab or Atlassian Bitbucket if you prefer. You can still store your own scripts and analyses and the like on there. Larger amounts of data, you will probably have to have something a bit more robust, as it says here, in place, something which allows for large data to be stored. rsync is useful. We talked a bit about that yesterday. That has the extra options like the archive option that lets you just move newer files rather than everything. And because everyone will generally be getting access to ARCHER2 through a project which will have a limited duration, you should make sure that you have a plan in place to move your data away from ARCHER2 before the project is essentially before access finishes. And yeah, and there's more information there, again in the documentation. But yeah, the point here is that your data really is your responsibility. So you're probably all aware of this anyway, that you should keep multiple backups of everything that you're able to. But just to really make sure, please try to not lose data. Even again, it's far too easy to accidentally RM something you didn't mean to. So if you're make sure that you've got data backed up even for situations as trivial as doing an accidental RM. Transferring data, we mentioned again yesterday. a little. Between ARCHER2 and institutions and the universities you're at, there's probably a good transfer speed over the network, but that there may be slowdowns because you may not be moving data to a file system, to a target file system, which is as high performance. So you may end up being limited by the performance of the place where you want to move your data to. You spoke about creating archives containing all your data rather than transferring lots of small files. You may find that you get an improved performance and better transfer speeds if you instead archive your files into a single file or a few large files rather than many small files, because each file transfer has an overhead attached to it. Of course, if you transfer fewer files, then you only have the overhead a few times rather than many times. That comes in both in the encryption and in the transfer itself. Network speed, so as I said, if you're moving data perhaps to institutional backup you have at your university or whatever your institution is, then the network may be good. But if you're perhaps backing up to your laptop, if you're working from home or the like, then you may be limited purely by the Wi-Fi speed you have. So it could be a good idea just to get out an Ethernet cable and perch your laptop next to your internet router for a bit, just to increase the speed there, if that could be a limiting factor in how quickly you can move data. And finally, firewalls can also impact the transfer here, because if the firewall is filtering network packets, then that will itself have an overhead. And again, a good thing to do, I think this is sort of very good general advice, is to, before moving data, archive it into a tar or a zip file, because this cuts down on a lot of the overhead operations. Some things you can do are to do tests. So rather than spend a whole day downloading a single huge tar archive, it may be good to create a smaller archive of just some of your data and try downloading it to a few different places or over a few different network connections to try and see what works best. And then you can go ahead downloading your full data set using what seems to be the best option, the best setup for maximizing the data throughput, maximizing your network transfer speed. So the points we've been going over in this session here are to be careful how you use the login node. You can do things like building, setting up runs, creating directories, and the like, remember, but running computationally intensive programs is not going to be a good idea. It's going to use resources that could be used for other things in the login nodes, unless you really do just want to make sure that they will start up and then you quit them only a couple of minutes in, just to check that that's okay. Your data is your responsibility. I guess really trying to bang it in here. Don't run stuff on the login node. Don't be a bad person and run stuff on the login node. So I guess I'll add another point. Don't be a bad person and run stuff on the login node again. Okay, great. Let's move on to the next section now, which is using the safe. Again, we talked a little about this yesterday, and you'll have seen some of this from when you were creating your accounts. So the safe, remember, is a website. It's developed here at EPCC, and it's essentially the tool that lets us do all of the admin and account and project control on ARCHER2, as well as a few other clusters we run actually. For you, this means this is how you can manage your ARCHER2 account. This is how you get access to extra software packages. It's how you can see how many resources you have available. It's how you reset your passwords if you forget it and can't log in. It lets you record research outputs into your use of ARCHER2. You can bring up plots showing you your historical use of the service. You can see how many CUs you used when, your disk space usage. And if you are a project leader or manager, or so if you're a PI project, it gives you control over the project. You can create subgroups within the project. We spoke about those yesterday when we were looking at the file system. You can choose who on the project gets to use which resources. You can, if you want, set disk space quotas for users on your project. So I think everyone's already got their accounts done. So I think yesterday it seemed everyone was okay with that. So you've probably all gone through the safe and have created your accounts. And we'll just take a look at some more here. So first thing, and this does I think occasionally trip people up, is that you do have two accounts associated with ARCHER2. So you have your account on the safe website, which you just use to log in to the safe. And then you have your ARCHER2 login account itself. So the machine account, it's often called. And what's more than that is presumably you will all, I think a lot of you were saying that you would be using ARCHER2 in the future, or possibly are already, in which case you've probably got multiple login accounts on ARCHER2, just on that one safe account. I've got a whole load of different ARCHER2 accounts at this point. But if you log in and go to the login accounts section on the top bar, you'll see it drop down and you can take a look at all of them individually. And a lot of you, if you use EPCC Tier 2 systems, Cirrus is the one which we run here at EPCC as well, you'll also see those accounts on there. Thankfully, it will tell you which account is for which system because it will have an @machine name after it. So there is again a lot to do on the safe. It's a very, very powerful tool, so we can't go through everything, but we're going to go through the most useful points. So something you can do if you want is you can use your institutional single sign-on to get logged on. You may prefer to do that rather than to keep a safe password lying around. Personally, I don't, because as we spoke a little bit about yesterday, I use a password manager, and so that makes it simple enough to just go ahead and use that. Changing your email notification preferences is actually fairly important. Sometimes people, I think, don't realize that they aren't signed up to the emails that are to the email notifications which can go out from time to time. And some of these are very important. There'll be notifications for upcoming maintenance, or they might be notifications that the system has had to go down unexpectedly or is unable to run jobs. So making sure that you get these emails if they go out is fairly important. You can go, so the thing to do is to log into the safe and go to your details and then update email settings. And personally, I've checked everything there because I think if information goes out, I would prefer to know it. So I would definitely recommend seeing if you do have those turns on, and yeah, my personal recommendation would be to get everything which can go to you, just so that you stay aware of what's happening on the system. As we said, there can be multiple machine accounts on a single safe account. They will be listed under the login accounts menu on the top bar. You can just mouse over that, and as I say, they'll fall down from there, and you can check out whichever one you're currently wanting to know more about. The main things you'll probably be doing there are checking out which resources you have available. So you'll see all of the budgets associated with that account. There'll be at least one, which is the budget associated with the project that you created the account under. If the project PI has decided to create subgroups to more tightly control which resources go where, you will see those budgets listed as well. You may, I don't think as many people do this, but you may have a guest budget as well from a different project, in which case that would also be listed there. What's important is that you can always go there and always see how many CUs you have available. And if your PI is also putting storage quotas on subgroups, you'll see those quotas listed as well. Picking up your initial password is what you will have done if you've used it to log on already. So when you log in for the first time, you just grab the password from this page and use that to log in. There are a couple of things to be aware of. Maybe, I guess you've all probably done this, but maybe if you are helping other people on your project, sometimes people aren't aware to get their password on that page. I've helped a few people who haven't known that they have to go there just to get that one-time use password. So maybe if people you work with aren't sure how to get logged in the first time, you can tell them they just need to go there and get that password. The other thing to note is that the password stored on that page, the password that you see when you click on that button to get that login password, doesn't update when you change it on your first login. So if you once you set it on your first login, or if you reset it later on, it won't change once you do that first login and go through the enter your password and then enter your new password twice process. You'll choose your new password, but from that point on, that password is only known to you. The one on the safe won't update to show what that password is. So you have to remember you have to remember yourself what that password is. And then, yeah, of course, you can reset your password there if you need to, in which case you go through the whole picking up your password again before changing it to a password of your choice process. Something else is to add SSH keys to your account. So you probably added a key to your account when you created it. Something I think most people want to do is to be able to log in from multiple machines. You maybe have a desktop at the office and a laptop or another machine at home. And of course, you want to be able to log in from any or all of them. And you can do that. You just create an SSH key, a new public-private SSH key pair on each new machine you want to connect from. And then go onto the safe and upload the new public key to it, and then use the private key for the new machine when you want to connect from it. Something you shouldn't do, I'm just going to note here, is to just copy your public and private key to every machine that to every new machine that you want to use, because that essentially defeats the point of using the whole public-private key pair system. The whole idea is that if the private key never leaves the system that you create it on, it should in theory remain secure. It should just be the public key alone which goes walkabout, so to speak. So you can just, it's a fairly easy process either on Windows or Mac OS or Linux to create a new key pair. Should just take a minute. So just create a new key pair on a new machine and upload the new public key to the safe, and then you can access your account on ARCHER2 from however many machines you want to use. And finally, if you want to use licensed software on ARCHER2, so licensed software which is already installed by the CSE service, so this will be packages like CASTEP and VASP and PyChem Shell and the like, you will need to go onto the safe and then onto your account, and the request access to package button will then let you say which software you want to use, and it will ask you to provide your license details. We can check that and then give you access. Nearly at the end here. So something else we do is we allow you to add details of your research output, so papers or other publications, anything which gets a DOI, and you can add that through the safe. So you just go to your details, publications, and if you do generate output with ARCHER2's help, I'll say, you can add it here, and that helps us to make the case to the UK government to carry on supporting HPC. It says to them, look, ARCHER2 is good, it's helping this person produce this research and those people produce that research. It's worthwhile that we keep this service and services like it in operation. Finally, if you want to know how you're using the system over time, perhaps you want to take a look at the jobs you've been running, see how many CUs you've been using over the past month, say. Make sure that you're on track for perhaps some goals you have, or to make sure you're not falling behind in your use, not using too much. You can use the reporting functionality. You go to service information on the top and then reports. And you can take a look at this. You can see the details of single jobs, or as I say, overviews of usage over given periods. And you can just take a quick preview of that by just getting a web page up in HTML, or if you'd rather get a PDF with the graphs in it, you can do that, or you can just grab the data in CSV format if you want to do anything with it yourself. Okay, with that point, we're on to lunch, thankfully, and let me check the schedule. I don't think we're too far behind. I say this afternoon's session is very flexible, so we can essentially make our way through that as we like. Yeah, so we're only 15 minutes behind. So I think we can take the full hour there, come back at 1:30. Then we're going to have a short session on next steps for using ARCHER2. And we'll finish up with that, as it's called, the bootstrapping your use of ARCHER2 session. Remember I asked you yesterday if any of you have any codes which you would like to bring along and see if you can build and get running. We'll be here. We can give you help and advice on doing that if you would like. If you would prefer, we also have an exercise where we have some GROMACS input data, and you can attempt to do some profiling runs with it, work out, you can do some benchmarking. I will also, after the question we had this morning about explaining how to connect to a running job with GDB for HPC, I'll do a quick demonstration of that for anyone who's interested. I think that's worthwhile doing because, as I said this morning, I think GDB for HPC is actually really useful. So I'd be happy to show anyone who's interested how to do that. Otherwise, there's no requirement for that session for you to stay around. So, so if you do feel at that point that that's enough for today, then you'd be very welcome to head off. Okay, great. Thanks. So So I'll let you all get away now, get something to eat to re-energize yourselves. I'm definitely in need of more caffeine to stay awake, so I'll see to that before anything else. Otherwise, I'll see you back here again at 1:30. Okay, have a good lunch, everyone.